Hello, class, and today we'll be talking about work, power, and energy. Now, starting off with work. Work is the product of force and distance, meaning the formula is work done equals to force times distance. Now, the SI units of work done is a joule, but we can also get the SI unit by the formula. Work done equals to force times distance, meaning the SI unit of force is newtons and the SI unit of distance is meters. So work done can have the SI units as Newton meters. Now, what is a joule? A joule is defined as the work done when a force of 1 Newton is moved through a distance of 1 meter. Now, work can also have other units such as kilojoule, which is 1000 joules, or megajoule, which is 1,000,000 joules. Now, let's look at an example. A force of 15 newtons moves an object through a distance of 200 meters in 40 seconds. Calculate the work done. So work done equals to force times distance. In this case, the force is 50 newtons and the distance is 200 meters, meaning that the work done is 50 times 200, which means the work done is 10,000 joules. Now, I hope you've understood work. Let's move on to power. Now, power is the rate of doing work, or is work done over time taken, which is also the formula, by the way, meaning work done, power equals to work done divided by time taken, which can also be written as force times distance divided by time. Now, one other important thing to know is the SI units for power is the watt. But just like we did for work done, we can find other SI units from the formula. Now remember, the formula for power is work done over time taken. So the SI units for work done, remember, it is the joule, and the SI units for time is the second. So our other SI units is joules per second. There are also other small units such as kilowatt, which is 1,000 watts, a megawatt, which is equivalent to 1,000,000 watts. Let's look at an example. A machine lifts a load of 5,000 newtons through a distance of 10 meters in 5 seconds. Calculate the power of the machine. Now remember, power equals to work done over time taken. They didn't give us work done, meaning we have to find it. Since they gave us force, they gave us distance, and they gave us the time. So work done equals to force times distance, right? So power equals to 5,000 times 10 divided by 5, which is equal to 10,000 watts or 10 kilowatts. Now, let's move on to energy. Energy is simply the ability to do work or the capacity to do work. Now, this is no harder, but we're going to move a little farther than we did for work and power. The SI unit for energy is the joule. Energy is very special. Energy can exist in various forms that include mechanical, thermal, chemical, electrical, atomic, so many others. Now let's look at the law of conservation of energy. The law states that energy can neither be created nor destroyed, but can only be changed from one form to another. For example, how chemical energy can produce light energy and heat energy. Now, there are various sources of energy. Sources of energy are raw materials for the production of energy. These can be classified into two. Number one is renewable energy sources. Renewable energy sources are sources that cannot be exhausted. For example, solar energy. This is energy trapped from the sun by solar panels, and you can see that cannot be depleted. Number two, the second example, hydroelectric power. This is energy trapped from falling water, which turns turbines connected to generators. The third example is wind energy. This is energy trapped from wind, which turns turbines connected to generators to give us electricity. Now let's look at non-renewable energy sources. These are energy sources which, when they are used, cannot be replaced. For example, fossil fuels such as oil, coal, natural gas, and so on. These are formed from remains of plants and animals that have accumulated over the years. Number two is nuclear energy. Now, let's look at mechanical energy. In mechanics, energy can be divided in two types, namely kinetic energy and potential energy. Kinetic energy is energy possessed by a moving body. For example, a bullet in air, a person walking, a car driving, and the formula is also very simple. Kinetic energy equals to a half mass times velocity squared. Now, the second type is potential energy. Potential energy is energy possessed by a body due to its position, such as a person standing or a car that is at rest. The formula for potential energy is mass times gravity times height. And the SI units for these two types of energy are the same. It's the joule. Let me give you an example to do with kinetic energy. A 4 kilogram rock is rolling with 10 meters per second velocity. Find its kinetic energy. Now, kinetic energy equals to a half mass times velocity squared. So in this case, it will be a half times 4 times 10 squared, meaning a half times 4 times 100. This will give us 400 divided by 2, meaning kinetic energy equals to 200 joules. Let's look at an example of potential energy. Find the potential energy of a rock weighing 4 kilograms in mass on top of a 10-meter tall cliff. The potential energy in this case equals to mass times gravity times height. Note that gravity equals to 10 meters per second squared. So potential energy equals to 4 times 10 times 20, meaning that potential energy equals to 800 joules.